Okay, so I want you to find 3 points on this vector, and what's its direction, what's its magnitude, the speed, which I hope you know is kind of related to the magnitude, and describe a vector parallel to it, describe a vector perpendicular to it, and then move the original vector to start at 1i plus 2a minus 3k. In other words, the point 1, 2, negative 3. Okay. I heard some person indicate that they didn't understand one of the questions. Okay, so obviously give yourself a break for that. If you didn't understand the question, you probably wouldn't have done it right. So, all right, pause for a second here. All right, so here we go. Name 3 points. Well, one of the points that would be easy to name is 0, 0, 0, because it's on that point. Okay, it starts with that point. And then another point that would be easy to name is you just stick in a 1 for this. If I put in a 0 for it, that would give me this original thing. But if I go back to putting a 1 in here, then I'd have the point negative 2, 1, and 7. Does that happen for every vector? No, because this started at 0, 0, 0. If it's like after you move it to start here, then you can't just grab this as a point. This happens to only be a point on it because it started at 0, 0, 0. But you always move it in that direction. That is its direction right there. So that's number 2. But anyway, I need to name one more point on this. Obviously, I'm stuck in 0. I stuck in 1. I'm probably going to stick in 2. And so then I'd have negative 4, 2, and 14. If you put in something else, as long as you put in like a 3 or a 4 or a 5 or something like that, you would just have to multiply it by these numbers right here to find your other point. So how many of you have 1 and 2 right? Okay, good. Then number 3 is the magnitude. The magnitude is if you wanted to walk from here to there, you could go down 2. No, wait, that first one's left and right. So left 2, up 1, and then depending on the orientation of it, in your case in this classroom, it'd be out 7 this way. Again, that would be 2 to the left, up 1, and 7 out this way. So I'm going to move this thing to be in the right spot. 2 to the left, up 1, and then 7 feet this way. So that's in the neighborhood of right there. I will try to find a better spot like there and then tilt it. There we go. Okay. Maybe a little higher. All right, so there's your vector. All right. Now, its magnitude is either I could walk straight lines over, up, back, or you'd probably take the shortcut. The magnitude is then from here to here, which is kind of like a hypotenuse of a triangle. And it ends up being the square root of 2 squared, 1 squared, and 7 squared, which is 54. All right, square root of 54. That is a distance. Yes? Yes, you'd find to write it as a column vector. This is the direction part of your vector. Okay, so on to speed. Speed is, well, distance equals rate times time. And rate is distance divided by time. See, rate is distance divided by time. And therefore, our distance, which was root 54, has to be divided by a time. And how long did it do it in? 1. Because you can figure it out if you had to. You could stick in a 1 right there and then find out that the distance was those numbers right there, except square root of them. So anyway, square root of 54 over 1. So it's root 54, which is about 7.3 feet per second. You did not have to use a calculator to get that. You could have said root 54 feet per second. On to number 5, a vector parallel to it. You'd probably want to just use the same exact dimensions, but does anybody think it through a little more thoroughly and do something different than the same exact direction? Yes? If we want to be parallel to it, we got to be going the same direction as it, right? So you need the same direction vector, but you can do something to it. you could make them all negative of each other, then it would still be parallel to it. So in other words, I make one going this way, and then I make one going the exact opposite way. Those are parallel to each other. So instead of going the same way, this could be going that, now this will be parallel. Cool. Okay, what else you got for parallel? You could also, you ever heard of the 3, 4, 5 triangle? You ever heard of the 6, 8, 10 triangle? It happens to go the exact same way. So you could make it -4, 2, and 14. Does that make sense? If you go double the distance in the same direction, you go double each of them, then it'll still be moving in the same direction. So I bet most of you just use the same one, but you could have said -4, 2, and 14, for example. All right, any multiple of it. Perpendicular to it, you had to find something where the dot product with it would equal 0. I told you before, you can't say 0, 0, 0 because that one is parallel to it and perpendicular to it at the same time. And it's skew to it, which parallel, perpendicular are two options. The third option is just that they're not parallel and they're not perpendicular, and that means they're skew lines. Okay. So anyway, I hope for your perpendicular one, you're going to test it yourself. If you take its direction vector and you multiply out and get its dot product, what should it equal? 0. So you could add any starting point. I don't care. You could add anything like lambda or p or t. But these numbers, these three numbers, when you take their dot product with the other one's direction vector, it should equal 0. So who's got an option that would have worked? Sir. All right. So this makes -4, -14 total. +14 cancels it all out. Perfect. That one is perpendicular. There are lots of options. Okay? All right. So moving on to make it the original start at this point. Okay. 1, 2, -3. So all I have to do is put a 1, 2, and a -3 there. That make sense? All right. So that is pretty easy. All right. One more. This one you need a calculator for. See if you can tell me the angle between these two that I'm about to give you. Yes?
If you were to be asked to like move the origin of it, but it hadn't started at 0, 0, 0, would you just...
It's a good question. Then effectively you'd be given 2 points. Maybe I should do one like that. That's probably a good idea. I'll call it question 8. I'm going to give you 2 points. 1, 2, -5. And the other point, again, these can be anything, -6, 2, and 1. I want you to make me a vector that goes through this point and this point, but I'm going to ask you to make it go like this, where the head end is at the -6, 2, 1. Write me a vector for that, because the question you asked me really would be solved by that. You know 2 points on it now, so the one that's got the pointy end on it, that's the head end. Here, head, tail, pause for a second, let me try that. Okay, so the answer to the question number 8 there is the black vector, and that one gives you, again, the vector that has a tail at 1, 2, -5, and the head at -6, 2, and 1. Now, if I give you this other blue vector down here, now you got 2 vectors. Tell me if they're parallel, they'll never touch. If they're perpendicular, they could touch, and if they're skew, they are lines that would not touch at all. Okay, and then there's one other option, is they touch, but they're not perpendicular. All right, I'm not telling you which of these this is, but you should be able to figure out whether they are parallel to each other, whether they're perpendicular to each other, whether they touch each other and are not perpendicular, or if they never touch each other. Who has a theory on which one these are? Nobody knows yet. All right, I'm going to give you a little more time. Okay. Did these cross? Some people say that they cross. All right. So if you just solve the top two equations, if you just look at this one and this one, you're going to get -8 lambda is equal to -7 lambda plus 1. That's the top one and then this one put together. Okay, you can solve that. Why can't you just solve it then? I mean, I found lambda because it doesn't work on the other two. All right. Sometimes you can make it work on one of the two. Does it work in one of the two? It works on two of these sets of equations, but it doesn't work in all three. So in other words, you have to check all three sets of equations. There's the red one, y equals 2 plus 0 lambda, and y equals 2 plus 0 lambda. And that one is just like 2 equals 2. So that one isn't a problem. It's the third one where I believe it's going to not work in there. But moral of the story is, when you solve these, you set your little equations up and you solve your systems of equations. Now, I've got one of those that's all set up here, this one. And here's an equation. All I have that's missing off to the side is the x, y, and z, okay? So this will just make it doable to see the two equations. And do you see that this gave me this top equation, and then the next one will be from the next line, etc.? All right. So if I move these up, I can move this up here and set them equal to each other. I can take this black one, which again came from here, 1 plus 0 mu, and I can put it there. And then I can grab this one and put it there. Oop, that's all right. And then I'll say equals, equals, equals. All right, and then I've got a system of 3 equations. And when you solve this one, you can solve the top one and the middle one and get an answer. And then the question is, can you put it in this third one and to have it work? And the answer on this one is yes. If it works on all 3, then you'll have it. Would you please solve this one right now? I've got the equations set up for you. I'll pause where you give that one a try. So, did you get an answer? So, did you get lambda? Right, this one right here should have told you lambda just all by itself. Just solve it and you got lambda. What is lambda? Lambda's got to be 1. Now, how do you know for sure it's going to work then? No, not until you actually plug it in tandem with the other thing, which is mu. So we got to figure out what mu is. Well, once I know lambda is 1, I'm going to stick it anywhere I want. So I'll stick it up in here and put a 1 there. So then it's saying 1 plus 1 times 1, which means 1 plus 1, which is 2. 2 is equal to -8 plus 5 mu. So then I'm going to add 8 to both sides, and I'll have, let's see, so that's going to be 10 is equal to 5 mu, and then mu must equal 2. So then I know lambda and I know mu. But if you don't check it in that third equation, you're just guessing that it's going to work. I'm going to check it now. Stick a 1 here, stick a 2 here. Does it actually work? Yes, it does. That actually is a true statement. 2 is equal to, all of that turns out to be 2. So yeah, it works in all 3 equations. Then you know you've got lambda and you've got mu. Okay, so do these touch? No. Because at time one of them's going to get to the magic place where they cross. And at time 2, the other one's going to get to that magic place where they cross. So remember, these two might cross in space and time, but they might not be in the same space at the same time. This one might go this way, and now this one went that way, and they would have been at the same spot, but they weren't there at the same time. This one was there at this time, for that lambda is this one, and this one's at the spot at that time. What is the spot? Would you please solve right now and figure out the spot where these two cross each other? If you know they cross each other, you don't need to solve it for both of them. I've told you they cross. So all I really need to do is stick in lambda's 1 right here, and you'll get 1 plus 1 makes 2, and then what's the rest of it? 2, 1, 2. 2, 1, 2 was the spot where they would have touched. Why didn't they touch? Different times. One was there at time equals 1, one was there at time equals 2, and therefore they don't hit at the same exact time. And therefore, that's the hard part, and that's what you're going to be doing with the bowling ball lab, is trying to get them to be at the same spot at the same time, not at 2 different times. All right, so your homework for tonight is this green packet. And it is not the whole thing. That would be just awful. I haven't graded homework in a while, and I got some stacked up, so I'm going to grade some probably tomorrow, because I have plenty of review days here between now and when we do our test on Tuesday. So basically, I didn't teach you anything new today. It was all review. It was just some of the more challenging review questions. And let's look over the first couple problems in this packet together before you walk out the door. You're only doing 1 through 5. No, as I mentioned before, this one was too easy to put in the grade book. The other quiz we took out of 7 points, that one I already got from some people, I didn't get from everybody. Yes, we're going to put that in the grade book. This one was just for practice. 1, 2, 3, 4, 5. All right, I guess just do problems 1 through 5. I will warn you that number 2 is tricky because you have to make them perpendicular. Do you remember what that means about their dot products?
0.
Dot products have to be 0. So if 2 is tricky, don't let that mean you don't finish the rest of it. You can always skip it if you get stuck on one and it's taking you way too long. That's all I got for the video for today.